So how we can find out the efficiency of this heat pump is using this statement. Actually, it is defined as the ratio between the heat removed from the process and the work required to accomplish this heat removal. Means how much amount of work is required, how much amount of energy is required to remove the heat from the process is called as efficiency of heat pump. Heat pump is nothing but this complete unit. This complete unit is called as heat pump. Okay, the function is to transmit from one from heat from the lower elevation to the higher elevation. In this way, the heat is transferred from the lower elevation to the higher elevation. This complete process is heat pump. So how much you can see in the evaporator here, QL is mentioned, QL. So how much heat is removed by this evaporator or this complete process. To remove that heat, how much energy is required, that is W, you can see here, required, and this is the QL. So that is defined over here. So this definition is important about in respect of this heat pump. Then the types of this chiller, as we are well now aware, air cooled chiller and water cooled chillers. There are two types of chiller. So this is one picture of actual chiller process. You can see here the example of water cooled chiller, and they are connected in they are arranged in series. You can see here this one is first chiller, second chiller, third chiller. The water cooled chillers has the advantage of high heat capacity of water to facilitate refrigerant chilling. So this type of chillers can cool more. We can get more chilled water from water cooled chiller by comparing with the air cooled chillers. The typical coolant used in the water cooled system is a mixture of water and glycol, which is circulated in the seal network of tubing. So actual this mixture is used, actually we call refrigerant, and that is actually this water and glycol. This medium is used for this as a refrigerant for this type of chillers, which is circulated in seal network of tubing. So seal tubings are used. Cooling occurs when the chilled refrigerant is passed through the heat exchanger. So this complete process, we know how the cooling will be taken place in the chiller. That block diagram we are well aware. Now this there are different parts. There are several essential components of this water cooled chiller. Are, we know this cooling tower is one, then condenser water pump, then makeup water pump, this actual basic chiller unit, and these reservoirs also called as thermal energy storage reservoirs. So these are the parts of this water cooled chillers. What are the benefits we get from the water cooled chiller? Actually, we are comparing these two. We will not get started on air cooled chiller. First, let us discuss water cooled. Some users may prefer these chillers because of the smaller size. So this is one benefit we can say, smaller size, and not actually very small size. As compared to air cooled chiller, they can say smaller size, not very small size we can say. They occupy, as compared to air cooled chillers, these chillers also feature higher efficiency. This is the second feature of this water cooled chiller. They have higher efficiency and last longer. This is the last one. They can be useful for longer durations than the mentioned alternative. Those who would like to equip with this to be placed indoors may find water cooled machines desirable. Okay, so more cooling can be get from these water cooled chillers. So these parts of these water cooled chillers are, we are well aware. I will not cover this again. The evaporator. What is the function of evaporator? That already we knows. Okay. So okay, some may be joined, may not be joined in previous sessions. What is the role of evaporator? The evaporator role is to produce chilled water The device release water at about many different places, different temperatures are mentioned. Here 6 degrees Celsius is mentioned. About 6 degrees Celsius chill water we get from this evaporator, and it pushes that to the with the help of pump to the air handling unit, and the heat will be exchanged at air handling unit, and the return air is about 12 degrees Celsius that comes from the air handling unit, and it returns into the evaporator. Again the process will be taken place, and we get 6 degrees Celsius from the evaporator with the help of other parts. Condenser is also very important part of this, converts the vapor things into the water again, and again the heat will be exchanging taken place here. Let us say we get 27 degrees Celsius with the help of cooling tower, and as it is 32 degrees Celsius from the condenser to the cooling tower, and at cooling tower it is reduced at 27 degrees Celsius and come back into the condenser and goes to the, in between this cooling tower plays the role. This is one picture of air cooled chiller. In that main role is performed by the fan. There is inside a fan that plays the role of chilling, where the aesthetics of these environmental conditions or water access restriction, as we sometimes what happen due to the water restriction, as we know that the importance of water nowadays, so that these air cooled chillers are developed, because many places it is not possible to because in water cooled chiller the continuous supply of water is required, more quantity of water is required, so in some places that may not be available for this, so in that cases these air cooled chillers are preferred. Okay, so they are also good type, but the chilling is not as that level what we can say that can be given by water cooled chiller. Here the combination of this ambient air and water spray is used. Okay, ambient air plays the important role, and very small water spray can be used in this. The ambient air in natural draft coolers, the external air can be taken, and this water will be sprayed in the form of spray, while in air cooled chiller use a current of ambient air, so they can't use this water spray, they can directly spray the ambient air. So what are the benefits of this air cooled chillers? You can no cooling tower required, better environmental stability, no water wastage because water is not required, low maintenance cost, easier to operate and control, tower operate and control, tower freezing and tower bypass absent because there is no freezing, and that chemical cost avoided, no chemical is required for this, directly fans are used for this, water cost avoided especially in cities, we know the billing of this, no water problems to deal with the case of disaster. So all these are the advantages of the air cooled chillers. So this slide shows the comparative picture of this. The left side is air cooled chillers and this right side shows the water cooled chillers. So you can see that there is no cooling tower over here. Okay, the cooling tower is not required. The air contains this air will be get this conditioning will be taken place at the condenser itself. There is no requirement of any cooling tower additional. Only that part is absent. Other part is remain there. So what are different parts of this cooling tower that are highlighted here? Some of the parts are mentioned. For any cooling tower, there is a eliminator, there is a spray nozzle and header, there is a PVC fouling, there is a mesh, float wall, bleed wall and body. These are the 7 parts are there in any cooling tower when it is water cooled chillers. For example, one picture I can show you how the this complete cooling tower will be look like. You can see It's very easy, not difficult thing. You can see, I will start from the inlet. You can see the inlet at the bottom. From this inlet, from condenser, from this will be coming from the condenser here. This warm water will enter here through the condenser, and that water will be distributed by the sprinklers. You can see the nozzle for the sprinkler. It will be sprayed like this. It will be sprayed on this particular portion. Okay, this particular portion is there, so it will be slowly move down the sprayed water onto the next layer, so that this PVC fouling is added here. This part is PVC fouling. What is that PVC fouling is mentioned here? The purpose of this PVC fouling is to reduce the falling speed of hot water, and it's similar to the beehive. Okay, so to reduce the speed of the falling, this PVC fouling is used. So this is PVC fouling. This sprayed water then enters into the second layer called as air inlet. So you can see this mesh. So this complete part is mesh for the air inlet. You can see this here, the air can be inletted for maybe mechanical drafting, maybe mechanical type of drafting, or maybe natural draft can be used. Okay, so the air will be get inlet in this, and the heat will get exchange over here to the air, and that water will get settled over here. You can see this portion in blue color where the water is settled, and that is the cool water. And there are some arrangement is provided like drain. So we want, suppose we want to drain it out, we can make it drain it out, and maybe again it can be passed to the condenser. Okay, so through this outlet, that cool liquid, cool water again entered into the condenser. So this will be goes to condenser. Again, this is the inlet from the condenser, and this is the outlet to the condenser. And the warm air, that warm air, you can see it will be can be exhausted to the atmosphere. You can see with the help of this motor and fan, it will be blow out. Okay, it will be blow out to the atmosphere. So in this way, cooling tower. So there are two types of cooling towers: natural draught cooling tower and mechanical draught. What is the difference? The fan is not used for the air circulation. You can see here, this air can be directly enters in this mesh. There is no fan over here. You can't see any fan this side. So this is naturally, this air gets circulated through this mesh, and then it will be only this motor and that used for the blowout. Okay, to exhaust that air to atmosphere, only for that purpose this motor is implemented, so that this fan is not present for circulating air. But here, by enclosing the heated air in the chimney, and it may be create pressure difference between the heated air and the surrounding air. Because of this pressure difference, air enters in the cooling tower. Okay, it required large hyperbolic towers, so capital cost is high. So the for the design of this tower, huge cost is required. The operating cost is low because the absence of electrical fans, but as the energy requirement is less, so that operating cost is less, but construction cost is large. So again, there are two types of natural draught cooling tower: rectangular timber tower as well as the reinforced concrete hyperbolic tower. There are the two subtypes of this natural draught cooling tank by the arrangement of this. You can see this one arrangement where the hot water inlet is given to the sprinkler nozzles, and in this way you can get here the cold water. So this type of arrangement is also there. So these are actually the dampers. So dampers are open and closed. Based on that, the natural air will come in, okay, in this simple way through this. And this may be the another one. You can see the another arrangement of this natural draught cooling tower. So in this this cold water, you can see here is the main outlet of this cooling tower. Here we get the outlet of cooling tower, and that we can pump to the condenser. And this is the this mesh filling, and then this additional parts are added here, like drift eliminator, then water spray system is here, and tower inlet is the air inlet is through this side. You can see the inlet for the air is through this side. It will enter here, and through this side cold dry air can be entered, and again the heat will get exchanged and it will be returned back to the atmosphere, maybe through this side tower outlet. Then mechanical or forced draught cooling towers, where actually the fan is used to circulate the air. This is the difference. The fan can be used to circulate the air inside the cooling tower. To rotate fan, it uses motor with speed of around 1000 RPM. The working principle is same as natural draught cooling tower. Only difference is here that the fan is mounted on the cooling tower. So how it can be look like, we can see here. Now you can see this air, the external air will be blow in with the help of this fan along with the motor. So this motor is used to pass the air of this external air to inside by improving the speed of that, so that the speed will get improved. And the other arrangement is same. You can see there's no, as the speed is improved, so automatically it will be blown out, automatically it will be blown out from this. There is no requirement of any blower here to exhaust that to atmosphere. By natural process it will be exhausted to atmosphere, and here the warm water will come in, and then nozzle and that same arrangement, and here it will be circulated, it will be stored here, and the storing, after that then it will be again passed to the condenser. Here it will be coming from the condenser, this will be coming from the condenser, and it again goes to the condenser using this. So this is called mechanical draught cooling tower. Again some difference is made about this. So some plastic filling is added to reduce the speed of filling. To reduce the speed of filling, some plastic fill is added over here, and some pumping mechanism is used. This pump can be this pump can collect the cold water from this cooling tower, and it will pass to the this cold water is circulated in this way by using this heat exchanger over here, and it will be again entered in this way. And here you can connect the again the pump and motors. When we want to pass it to the condenser, we can use this one, and the same again can be recirculated. The condenser water is not directly circulated here. You can see it will be coming from the condenser into the lower tank actually here, and this will be then pumping through this heat exchanger like this. So this arrangement is different than the previous one. Here it will enters directly into this upper section, and then to the sprinklers. Okay, but here that arrangement is not there. You can see that this arrangement is not there. It can be entered from the storage tank through the pump, and then it will be circulated to the condenser. So this is the difference.